Has this ever happened to you? You get a cool new toy and you have no place to plug it in. Oh no, now what are you going to do? Well, don't worry, we can help.
Hey guys, Adam here, your wiring guy, and today we're going to learn how to put in an outlet where there is no outlet. In our example, we had this Sonos portable music player right here that we wanted to plug in. We want to set it on the stand right here, but there is no outlet. And thank you to Shamir in New Mexico for making the suggestion. She was the one who asked how to put in an outlet, so this video is for her today. Remember, if you have any questions, comments, oh look, this is Hunter. He is you're supposed to be doing lighting and camera work today. Please get back behind the camera. You're embarrassing me. All right, so anyway, we're going to put in an outlet. Now, today's example is making a couple of assumptions. For starters, we're assuming that you have at least the most basic of skills here. Own some tools, drywall knife, screwdrivers, things like that, and that you have a healthy respect for electricity. Now, as in all videos that I make, the very first step that we're going to take is to make sure we shut off the power. So let's go do that now. All right, before we work on any energized circuit, the best thing to do is to shut off the breaker at the main panel. Now, my panel is not labeled very well, so I could just shut off every single circuit breaker in the whole thing, and that way I know I'm covered. But this one is my main. It's a 125 amp main breaker. So if I shut this one off, it's going to shut off everything in the house. If you're unsure, the best thing to do is just to shut off every single breaker. Now, I know that this happens to be my main breaker, so if I shut it off, all my power goes off. Probably a good thing to have a flashlight if you're going to go that route. Okay, great. So now you've got the power shut off. A couple of things we need to know. Now, in this example, we're driving a Sonos Play 1 music player. Very little draw on this thing, not a big deal. Let's say, for example, you wanted to put this in a basement bedroom and plug in a space heater. That's a bad idea. Most anything that you buy here in the States is going to have some specs on it. Now, this one in particular here, I'm sort of making this up as I go. This is a 1 amp player. So 1 amp, we're going to assume that this is probably on a 15 amp circuit with very little else on it, maybe some lights, a couple of other outlets in the room, no big deal. If you're plugging in a space heater, or if you're going to be plugging in something that has a big draw on it, you're probably going to want to get a dedicated circuit to it. You might even want to call an electrician in on this one, at least to talk you through what your options are. All right, so I'm going to make a couple of assumptions here. Now, I'm going to assume that we're working with a 15 amp circuit. You can verify that by checking it at the circuit breaker upstairs. We're also going to get into this box and have a look at it. So, assuming that we're working with a 15 amp circuit, we're going to go ahead and use the 14 gauge wire, which is rated for 15 amps. If you see this in the box that you're working with, this is a 20 amp circuit. And so we want to stay consistent. If you're working with 20 amp, stick with 20 amp gauge, 20 amp, 12 gauge wire. If you're working with 15 amp, you want to stick with a 14 gauge wire. We want the weakest link in the chain to be the circuit breaker. Okay, so enough on that. We can talk more about wire gauges later. Now, the next thing I want to talk to you about is a couple of different remodel boxes that are on the market. This is probably the most common one that you'll see at the home centers and places like that. It just has little tabs that will fold up, and as you tighten these screws, it'll create compression between the drywall and the box, holding it in place. These are ones that have come out recently that we use quite a bit. They're nice because you screw them in next to the stud, and then you have a little play to move the box in and out. They're super great in kitchens where if you're doing an installation and then the tile guy is going to come later and set tile in, you have a little bit of flexibility to move the box back out again. I'm going to do this one today because this is most likely the type that you'll have access to. You might be familiar with seeing the blue ones at the home centers. We'll go ahead and use the blue ones since that's kind of one of the more popular ones. The other tools that you may need for this, this is an interior, excuse me, if this is an exterior wall, there's a good chance it's going to be insulated. You may need a fish tape. Definitely going to need a drywall saw. So let's go ahead and have you guys come a little closer. Let's take a look at all this. All right, before we get too carried away with putting in our outlet, the very first thing we want to do is check our power source. In this case, it's a single pole switch, which governs a light that we installed in a previous video. So I know for a fact that this contains the power that we need, but it may not in your house. If you have a switch where you want to install the outlet down below, and somewhere else at the end of the hallway and at the other end of the room, there's another switch that governs the same light or the same group of lights that we're working with, you may have a problem. That's probably a three-way switch, and you don't want to take an outlet off of there, because you might find that you have power in that location where you think you should have power and put in your outlet. And then as soon as somebody flips the switch on the other end of the room, guess what? You don't have power there anymore. So make sure you're paying attention, you know what you're doing. This works great if you have a single pole switch, not so great if you have a three-way switch. If you have a countertop outlet, if you're doing this in a garage or the kitchen or something like that, and you need to get another outlet down low. If this was an outlet, same thing, you're in good shape. So, all right, so now we have our circuit breaker back on. We should be able to put one of our leads on one of those terminals and the other one on the white wire, which is our neutral. All right, that's showing us millivolts, which we're looking for actual voltage, so let's go to the top terminal. All right, 121.5 volts, that's what we're looking for to drive our outlet. So 120 volts is standard house current. Yours may be a little lower, a little higher, but that's what we're looking for. So now we know that terminal at the top of the switch is our hot. That's the one that we're going to be working with. So just make a note of that, and I'm going to go turn that breaker back off so we can work this safely. So now we've got our breaker shut off. We can tell that we're not reading any voltage on here at all. So we're in good shape. We can touch this all day long. Nothing's going to electrocute us. That's what we like to see. Okay, so now that we've got this box open a little more, you can see where I'm pointing this screwdriver here. That's where we already have one existing wire coming through here. We could probably even get our new wire through that same opening if we needed to. There's another tab over here that we could break out and use that for our wire. But before we do any of that, let's go ahead and get our outlet cut in down low where we need it. All right, so before we cut our hole for our outlet down low, there's a couple of things we need to discuss. So this box, we've already gotten that open, and you can tell just by looking at it, this box is screwed to a stud on the left-hand side. So we know we have a stud on the left-hand side. If we're dealing with typical standard construction, you should have studs every 16 inches. So our next one's over here, which means we have free reign to put our outlet anywhere in this bay space right here. Although the closer to underneath the switch are, the easier this is going to be on you. But just know as long as you're in that bay, you're in good shape. So this is a wall that I obviously built in my basement. Your wall is not going to have the luxuries of showing the screw holes where it's attached to a 2x4. So you can always do the tap method, or you can go out and get yourself a stud finder, or look in the box and you should be able to tell which side the box is screwed to. So enough on that. Now let's assume that you're putting this in a room where there's other outlets in view, or that you even have other outlets somewhere in your house. We should go ahead and try to match the existing height on the outlets. So in this example, I'm going to say that the top of my outlets in my house are at 16 inches. And so we're going to go ahead and put our box at 16 inches. Now the cover plate's going to come to right about there on both top and bottom, so I'm just going to go ahead and get it fairly close. And then I like to throw a level on there just to make sure I'm somewhat level. All right. And once you do that, you just kind of trace around the box with your carpenter's pencil. I like to use my level to kind of finish off the places that were hard to get to. Now, if you're dealing with an inside wall, good chance it won't be insulated, so that'll make your life really easy. If you're dealing with an outside wall, there's a good chance it will be insulated, making your life more challenging, which is why I would usually use a fish tape and just try to get that down through there into your opening, which we're about to make right now. Now, little tip, I always make my horizontal cuts first. Why do you suppose that is? Because if you can't see where your studs are, like you can here on my wall, this is going to give you a pretty good indication if you run into something. And if you run into something here, it's easy to turn your blade around and start cutting the other direction. So you don't need to get too aggressive or too deep with your cuts. Remember, there's probably going to be other wires. In some cases, there might be plumbing or drain lines. If you hit something, stop. You can always make a hole a little bit larger, look in there with a flashlight, see what you're up against. bit of drywall fell down into the wall. If you have insulation, that won't be a problem. It won't be a problem no matter what. Okay, great. Our new box is a perfect fit. So now what we need to do is to verify our gauge wire is 14 or 15 amp rated wire, and go ahead and get that in the wall. So let's go ahead and do that next. All right, well, if you remember from a few minutes ago, we decided that our top wire here was our hot wire. So this is the one that we're going to want to use to feed our outlet. So I like to get that sucker pulled off. Now we want to make sure that it is indeed a 14 gauge wire. So what I will typically do, well, I know because I've been doing it for a long time, you can just tell by looking at it, this is indeed 14 gauge, which is good up to 15 amps, but you may not know because this may not be what you do for a living. So what you can do is take your wire strippers, and if you look closely on your wire strippers, it says, well, yours may be different, but mine go from 10 gauge down to 18 gauge, and we suspect this to be 14, so we'll put it in the 14 slot, and it fits like a glove. If we go to the 12, there's a bunch of slop. You're never going to see Romex in 16, so Romex is either going to be 14, 12, or 10, at least for the stuff that you care about. So there's our hot wire there. What we're going to do now is we're going to go ahead and we're going to pigtail this one, and we're going to pigtail it because we want to feed both of our switch and our outlet off of it. But the first thing we need to do is we need to get our wire out for the outlet so we have something to pigtail. So let's do that next. Alright, so I'm just going to break open that second tab out of the box like that just to make sure I have plenty of room to get my new wire that's feeding the outlet down there. So all we need to do is just push about that much down there. And now let's go check our outlet and make sure we've got enough wire there. Alright, so now that we got our wire poked down the wall, as long as we don't have any insulation or anything like that, we should be able to just reach in there, grab our wire, and there it is. One of the biggest mistakes we see people make who don't do this a lot is they don't leave themselves enough wire to work with. You know, I've seen guys leave themselves 3 or 4 inches of wire to try to work with, and you know, once that's inside the box, that really only gives you about an inch or so. So what I like to do is strip my wire before I even put my box in, okay? And the way you want to do that is just very carefully using a very gentle, shallow cut. Just lightly score the outside of the wire until you get to about the last inch or so, and then you can go ahead and score it pretty good. Because if you damage that last inch or so, we can cut that off and start over. But what you do is use that score to do that, okay? That's going to show you the inner sheathing, which is fine. That's just the paper to protect the wire. Just go ahead and pull that right off of there. There's another piece right on the ground wire right here, same deal. Pull that off of there. Make sure you got a good 8 or 10 inches of wire to work with. And then you take your remodel box here, pick a tab that you like. I like that one. Get that busted out of there. Feed your wire into the box. Now this is important. Make sure your sheathing enters the box, good 1/2 inch. What you don't want to do, you don't want to see that, okay? Get your sheathing well inside the box like that. Fold the whole thing back in there. And then if you have a power driver, that's usually the best way to do these. You can sit there with a screwdriver if you want to and do it this way. It just takes a lot longer. The one thing you want to make sure of is that those tabs fold out on you. So you see how that works? Because once that tab folds out, it starts to build compression between the face of the box and the back of the drywall, holding everything in tight. So I'm going to go ahead and grab my driver and get this knocked out. Alright, so now that we got our box nice and secure in there, we're going to go ahead and strip out our wires. Again, I like to make things a little long because what we're going to wind up doing is we're going to bend a horseshoe in there, just like you've seen me do on other videos. Ground wire and our neutral wire. Now, the reason we do that is because if you've watched my other videos, you know that I'm no fan of using the stab backs. They just have a tendency to fail over time. Much more a fan of using the side terminals on the outlet and or switch. Now on the outlet, how do you know which one's hot and which one's neutral and which one's ground? Well, we know that green is ground the whole world round, so we're going to know that our bare wire goes there. Okay, so let's just go ahead and get that one knocked out of the way first. Go ahead and get that going around there clockwise. As we've talked about in other videos, you want your wire to go around there clockwise, so when you tighten your screw, it just pulls that connection even tighter. If we'd gone around counterclockwise, it would just loosen it. So on outlets, we have a white screw and we have a brass screw. So the white screw is our neutral, which goes to our white wire. That's true on all outlets, all devices. Okay, so we just go ahead and put our white wire on our white screw, going clockwise. Get it nice and snug. You don't need to get gorilla tight on it or else you're going to break the outlet, but you do want it to be nice and snug. Okay, the other screw I like to go ahead and tuck both screws in. You don't want any loose ends. You don't want something that can get caught up and short out on something, so go ahead and do the same thing to our hot wire. Go ahead and get that on there. Again, we're going clockwise to make sure that when we finally tighten that screw, it's going to wrap the wire even tighter around, so we're in good shape there. Take that second one, go ahead and get that locked down. So we got a good solid connection on all three wires. If you've seen my other videos, you know I'm a proponent of tucking everything nice and deep into the box, so that way we don't have anything shorting out when we turn our power back on. Ground wire looks good, hot looks good, neutral looks good. Let's go ahead and get everything tucked into the box. Use your driver or your screwdriver to tighten it in. Again, when it comes to my cover plate screws, I like to run it so the slot goes up and down. Your house, you do it however you want. Run it horizontally if that makes you happy. Run it vertically if that makes you happy. You could have it catawampus if you want, but that's how I prefer to do mine. All right, so let's go ahead and get it tied in at the switch up above, and then we'll be done. All right, so we got plenty of wire down there. We were able to get our outlet done. Same deal here. We want to make sure that we have plenty of wire coming out the face of this box. Again, you just very lightly score the Romex. You don't need to get too out of control. If you can feel the tip hitting copper, you're pushing too hard. So again, about 8 or 10 inches, lightly score it. You can always take your wire strippers if you need to and just kind of cheat that open a little bit where you scored it. See how I do that? If you're cutting through the paper, you're pushing too hard. You don't want to do that. Again, you want about an inch or so of that insulation coming into your box. You don't want those bare conductors poking out the back. I don't know if you can see that, but I do have let me see if I can get a light on that for you. Bear with me. Okay, can you see that? I'm using my phone here to show you that there is some insulation coming in the back of that box, which is what you want. You want some of that. And you want to make sure you have, 6 or 8 inches coming out the face. Now, if you leave too much wire, it just makes it all hard to get it all back into the box. But a good rule of thumb is about the same length as your pair of wire strippers. That's going to give you enough to work with. You want to pull this paper insulation off of here. You want to pull the paper insulation off your ground. That should just snap right off, no problem. And then, any guesses as to what we're going to do next? We're feeding an outlet here, so an outlet needs to have constant power. That's why we took this black wire off of here. So we're also going to need to refeed that to our switch, so our switch can have power to turn our light on and off. But there's our neutral, and there's our ground wire. So we're just going to tie those together and tie these together. Okay? So then our neutral has a constant neutral, our ground has a constant ground, our hot will have a constant hot, so our music player or our phone charger or whatever it is we plug in down low will be hot all the time and not ruled by the switch. There's our switch wire there. So we're going to make a couple of pigtails with some leftover wire that we just used. Okay. Actually, we're only going to need one pigtail, and that's going to be to go from the switch to our outlet, and then from our constant hot. Alright, let's start with our neutral wires here. You don't have to twist your wires together. You could put a regular old wire nut on there if you wanted to. And just as long as you're twisting this wire nut really hard, the conductors will twist together on the inside. I prefer you use a pair of pliers to twist your wires together. That way you know you've got a good, solid, positive connection. Let's go ahead and do our grounds without twisting them so I can show you what I'm talking about. If you just get it in there so the length is about the same, you twist this sucker on there until you feel like you can't twist it anymore. You're going to find that it does get twisted on there. Preference, however you want to do it. It's also possible to twist so hard you break your wire. Obviously that would be bad. Okay, so now we need to make a little pigtail here. Okay, short little 6-inch piece. It's just going to go from our switch to here. This is our new outlet. This is our hot line power coming in, as we determined earlier on in the video. Now, as long as you make sure your insulations all line up, you see where all the black insulations are roughly the same length. That's really what matters here. And then you twist these together like so. And if need be, you can always just cut off the very ends. Like so. And then put your wire cap on there like so. What you don't want is you don't want loose connections. Loose connections are what cause fires, they're what cause problems. You don't want any of that. So I don't know if you remember from another video, but we have this plate on this switch. It's kind of cool because it makes it so you can just strip this wire out straight and not do that horseshoe I was telling you about, and just go directly underneath the plate. If I could find my screwdriver. So check this out. Again though, you still want to put it on the bottom side of the screw so you get that counterclockwise action, is actually pulling the screw tight rather than loosening it. Even though this plate is creating pretty good pressure all the way across the wire, I don't think it's going to go anywhere. Alright, so again, I'm going to preach about making sure all your conductors are deep in the box, especially those bare ground wires. We don't want those to short out on our switch. Get everything out of the way. And then you can put your switch back in. Using a screwdriver or your driver. I like to use my driver. Power driver. So get the switch back in, get the cover plate back on, and then go turn your breaker back on. Alright, so we've got our circuit breaker turned back on. We've got an outlet being supplied off of this switch. This is a great way to go ahead and get yourself a convenience outlet if you have a portable music player, a cell phone that you need to have charged, something small. We don't want to go ahead and plug space heaters or anything that's going to have a lot of draw into this. Probably not even a computer. You want to talk to an electrician, make sure you're not going to overtax that circuit. But for a small load like a music player or a cell phone charger or something like that, no problem doing something like this. So I've got my plug-in tester here. We're just going to plug this in real quick. If the center light lights up, then we've done it right. And there it is. So we're good to go. We can now go ahead and plug in our portable music player and have music down here. So that's all there is to it. I hope you learned something from this video, and if you have any questions, please feel free to ask in the comments down below. Give our video a like, give our page a like. Any videos that you want to see made, hit us up. We'll get it done. All right, thanks, and be safe out there. Take care.